Welcome back to another exciting edition of How Do I Do This Anyways? Today what we're going to be looking at is how you take and make a slicer test for your box to make sure you're fitting within volume and mass parameters once it's been sliced. So got my box here. It is just my demo box. You should be able to do this exact same thing with your um, box that you have finally redesigned. And I'm just going to take it and just like every other thing, I'm going to go File, Export, CAD format. Well, first off, because we're going to do some other things to this, I'm going to go ahead and say Save As, and I'm going to call this Box 3 because I'm going to mess with this thing. And I'm going to show you why I'm going to mess with this after I first export this STL and import that into the slicer. Okay, so we're just going to export it as our STL CAD format. It's going to automatically want to rename it the exact same file name. Just let it do that and click OK and let it go. And it will export just like we've done all of our other ones. Now is where you're actually going to get to look at it in the slicer view. So the slicer is the program that takes your object, your STL, and turns it into a toolpath for the 3D printer to follow and to make your part. So I'm just going to go ahead and say load model file. And then I just got to find their file. Should be on your flash drive. Hopefully you saved it in your project folder. That would make the most sense. And let's see, test box 3. There we go. All right. Cool. Groovy. I love it. 154 grams? No way. That's much better. But, like, that's how it is. I can't open it or close it. And I'm pushing up against the limit on my print time. Okay. And another thing is, depending on your box, it might actually print this thing full of material. Okay. If it does that, you're going to have to chip all that stuff out. So what I want you to do is I want you to actually 3D print this in a fashion where it'll print much better. Okay. Also, like how this hinge is, gosh, that's not going to be very strong with the direction of the layers. Put that right like that. That would be the strongest pin right there. Still a decent amount of filament and all that. But where we're within tolerance, I'm going to show you how to get a better print because this right now, that is full of 3D printer filament right there. So what I'm going to do is I'm going to show you how to not do that. But I can't open or close this object. It is an STL. I can't change it in the slicer. Okay, at least not this slicer. So what we're going to do is we're going to take this box and we're going to edit it in our assembly view in order to actually behave more like a real box. So that way we can like do our stress test later, but also so that way we can lay it out flat. You see, I can try and just eyeball it and lay it out flat, turn it, but I'm not going to be able to get it to lay perfectly flat. Okay, it's not going to happen. So we're going to have to use the constraints and joint limits of our joints in order to do that. So we're going to go ahead, click cancel there. I want to go ahead and expand these. And you remember these flush constraints and the cylindrical constraints to hold the whole thing together? What I want to do is I want to see if I can use one of these cylindrical constraints. Let's see, the cylindrical constraint is there. And bingo. We got the box top and box bottom as our cylindrical constrained objects. So we can, we'll see if we can get that to work. We need to make sure that those are the cylindrical constraints. So I'm just going to go ahead and break these. Okay. I'm going to delete that constraint and I'm going to delete that constraint. And now what I'm going to be able to do is pull my box apart like that. Okay. Now, I need to make a cylindrical constraint between this hole where that would be, where the pin would go, and that hole where the pin would go. So I'm just going to go ahead and select that cylindrical constraint. I selected the cylindrical constraint simply because I want there to be more flexibility, and that way I don't have to be dead on with all of my air gaps adding up. Since I did the flush constraint with the outside of the box, I can do the cylindrical constraint with this barrel where the hinge should go, and then it should work. So it looks like it's working. So I'm going to click apply. Okay. Now click cancel on that. My pin is still out here. I'll get to the pin later, but this is behaving as it should. Now, what I need to do is I need to edit my joint on that. So I'm going to go ahead and say, let's see, where is it? Edit. There it is. Now I need to align the box. So I'm just going to go ahead and try and align the top of the box to the bottom of the box. Oh yeah, setting my limits. We want it to have an angular limit of 0. Now it feels like it's closed. All right, but that still doesn't stop the box from going like that. So now I'm going to go ahead and say, edit that again. And now my limits, I'm going to start at, first off, I'm going to set it back to 0 because it makes more sense to me. And then I'm going to go ahead and edit this thing and say that my starting position is going to be at 0. And you see how this is going with a positive arrow in that direction? Well, the box I want to open up negatively. So I'm going to start out with an endpoint of negative 180 degrees. Okay. And I'm going to click OK. And so what that did was it set it up so that the box cannot go beyond 180 degrees. Okay, so I'm clicking on the lid and it will not go farther than 0 and farther than 180. Okay, so now what I'm going to do is, since I want this thing to be a print in place thing, I'm going to go ahead and put my pin back in there first off. I'm just going to use a cylindrical constraint again. Putting that pin in that spot. And I'm going to click, yep, that looks all right. Apply, close that out. So now I got my box, I got my pin in there. So I'm going to hold this thing open at 180 degrees. Or if you know that there's a particular angle you need to drive that at and have it set at, you can right click and edit this thing, set your limit, and tell it where to go. Like if your box was best to be printed at 90 degrees, being straight up, you could type in 90, 45, groovy, it'll hold 45 for you. Mine is 180 because I want the two surfaces to print flat on the bed. I want the box top to be right there. So clicking OK here. And now looking at this thing, looking at my air gaps in between my parts, those look all good. And so now I'm going to go ahead and say save. And it's going to overwrite what I was doing. All right, now I'm going to go ahead and say File, Export, CAD format, and it wants to populate with the same name. I'm going to let it do that because I don't want that old version in there still. So I'm going to click Save, and it says, hey, it exists. Do you want to replace it? That's up to you. I would suggest replacing it if you don't want to be confused with names. Or, since it's always a good idea to have a fallback, I'm just going to call this 3B. That tells me that this is an update of version 3. So what I can now do is I can come in here and I can now load my plate by clicking right there. And I got 3 and 3B right there. So that's wanting to print 2. I can go ahead and delete the old one, and I can now go ahead and rotate this thing around as I want it to. Now, let's check your feeds and speeds of your slicer for the full slicer test. First off, you want to have a shell thickness of 1.2 millimeters. Okay, that is my standard slicer. That is, each side of the wall will be 1.2 millimeters thick. So if you have a wall that is like 4 millimeters thick, well, you're going to have a 1.2 millimeter side on one side and a 1.2 millimeter side on the other. And then in between that, you're going to have 10% fill. 10% is good and stiff enough. Now, the rest of these, the layer height should be at 0.2 millimeters. That's saying that it's going to be 5 layers per millimeter. And then you don't care, well, the 50 millimeters, you should set that, but we're going to be changing that. Also, make sure you have a raft, and you want your diameter to be set at 1.75 millimeters. Take a moment. Oh, by the way, in order to get to all of these settings, switch to full settings, not quick print. So next thing you need to look at, we are going to print all at once. Let's see, advanced. We have a 4 millimeter nozzle. Write that down. 25 millimeters per second is your speed. Just make sure all of these match. Okay. Pause the video. Check to make sure. This is going to affect your print speed. So as you can see right now, this is going to take 9 hours and 13 minutes to 3D print. That's within our 10-minute or 10-hour time. We are using 68 grams, which is within our 85 gram restriction. And in order to figure out your final volume, you click this scale button, and that's what it tells you your object actually is. You want to make sure that you are below 175 millimeters in your greatest dimension, and that your total volume is going to be under 1,000 millimeters cubed, or I believe it's 1,000,000 millimeters cubed. So take that times that times that, and you should be good to go. If you find that you are way above, you need to do a redesign. You need to change something. Maybe call me over, ask me for some help. So that is how you do your slicer test. You want to take screenshots of this. You want to take screenshots of this. You want to have it on there on the print bed, so that way you can discuss how you know that you are meeting those constraints. Hopefully this video helped you out. And of course, if you have any questions, let me know. Take care.